Welcome back. Today we are going to be reviewing Chapter 7 for our final exam. So Chapter 7 was all about exponents. In this chapter, the first thing we did is we learned some exponent rules, and we actually learned these shortcuts by writing things out the long way. What I'm going to do is, instead of writing things out the long way, I'm just going to write the shortcuts that we talked about, and we can definitely discuss where those come from when I see you in class. The first shortcut we learned was the multiply rule. So if we have x to the third times x to the fourth, so we have a multiplication problem, then the rule is you can take those exponents and just add them together. So my final answer would be 7. Then we learned the divide rule. So if we have x to the fourth divided by x to the third, then the shortcut is you can just take those exponents and subtract them. And 4 minus 3 is 1. We also learned that anything to the 0 power, so 3 times x to the 0 times y squared, anything to the 0 power is worth 1. So we could simplify this by doing 3 times 1, which is just 3y squared. We learned about negative exponents. So we said x to the negative 7th would really mean 1 over x to the 7th. We turn it into a fraction, and the same thing would go vice versa. If we had 1 over x to the negative 7, then the negative exponent would mean just put it back on the top, x to the 7th over 1. Finally, we learned the distributing rule. Whenever you have stuff inside of a parentheses to a power, you can just distribute that power to all of the powers inside the parentheses. So you would get x to the 10th, y to the 15th, and z to the 20th. To review how to use some of those rules, particularly when you need more than one rule in the problem, let's do some examples. So we said in this problem you would just add up all the exponents. So 7 plus 2 plus 5, which gives you 14. To review again the division property, you would just subtract the exponents. So 12 minus 9 would give you 3. Now to review the distributing property, the one thing that is tricky here is you do need to distribute to the 2 as well as the x cubed. So you would get 2 to the 4th power, x to the 12th power. And then to simplify, you could actually type in 2 to the 4th power on your calculator, and you would get 16 x to the 12th power. For problem 4, since x has a 0 power, it's worth 1. 5 times 1 would just be 5, so you would have 5y to the 2nd power. In problem number 5, we would just distribute that power again. So we would have 2 to the 2nd power, x to the 6th power, divided by 4 to the 2nd power, y to the 2nd power, and then we would simplify. So 2 squared is really 4, x to the 6th power, divided by 4 squared is really 16, y to the 2nd power, and 4 over 16 reduces, so we would just have 1/4 x to the 6th power, y to the 2nd power. Finally, in problem 6, we're going to review our negative exponent rule. So we're going to take x to the negative 4 and we're going to move it to the bottom. So we're going to have 2y divided by x to the 4th. The 2y is going to stay on the top, and just the x to the 4th is going to move to the bottom. Now we're going to review how to graph. So to graph these functions, we said first we were going to make a table. So what I'm going to do is I'm going to type in 6 parentheses, 1 over 2 parentheses to the 0 power, and I'm going to get 6, so I'm going to fill that in my table. Now I'm going to take that same thing, I'm just going to change the power to a 1 instead, and I'm going to get 3. I'm going to take that same thing and change the power to a 2 instead, and I'm going to get 3 over 2, which if I want that to be a decimal, because that does make it easier to graph a lot, I'm going to get 1.5. Now I'm going to graph these points. So 0, 6, 1, 3, 2, 1.5. And we said exponent graphs look like airplanes taking off or airplanes landing. And this would be a decay graph because it's going downhill closer to the x-axis. Now I'm going to do the same thing for problem 8. So if I were to graph this, I would do 4 times 2 to the negative 1, which gives me 2. I would change that exponent to a 0, and I would get 4, and then I would change that exponent to a 1, and I would get 8. If I graph those points, I get negative 1, 2, 0, 4, 1, 8. This one's going to look like an airplane taking off. And we would call this a growth graph because we're getting farther away from the x-axis. Now we had 2 different equations we needed to know about exponents. The first exponential equation that we needed to know was y equals a times b to the x power, where a was your initial amount and b was your multiplier pattern. Exponential growth, when there's a percent, we said we used this equation. Y equals a times 1 plus r to the t power. A is still your initial amount. R is your rate as a decimal. And decay is y equals a times 1 minus r to the t power. A is still your initial amount. And r is your rate as a decimal. So some examples of word problems that we needed to know how to do were this. You deposit $200 into an account that earns 4.2% interest. As soon as you see a percent, you know this is an exponential problem. Write a function that models your amount of money. So we know that our equation for percent and your growth would be y equals a times 1 plus r to the t power. In this problem, a is your initial amount, so 200. R is your rate, so 4.2%, which if you change that to a decimal would be 0.042. So my equation would be y equals 200 times 1 plus 0.042 to the t power. Now it specifically says here we want to know how much we have after 8 years. So I'm going to take this equation and I'm going to change the t to an 8 and I'm going to type that in on my calculator. So my answer would be $277.95. All right, now let's say you have a problem where it says that you deposit $200 into an account that loses money at a 5% interest rate. You still know that this is exponential because there's a percent, but we're going to need to use the decay formula. So the exponential decay formula would be a parentheses 1 minus r to the t power. A in this problem would be 200. R in this problem would be 5%, which is 0.05 when you change that to a decimal. So you would have y equals 200 parentheses 1 minus 0.05 to the t power. Now it specifically says how much money will you have after 5 years. So I'm going to take this equation, I'm just going to simplify this to 0.95, and I'm going to raise it to the 5th power. Now I'm just going to type that in on my calculator, which would give me 154.76 as my answer. Finally, if you have an initial population of rabbits that was 12, but you're doubling in population every year, write a function that models the population of rabbits over time. So because it says the word doubling, that means you're multiplying by 2. So I would use my general exponential problem, my general exponential equation, a times b to the x. A, which is your initial amount, was 12. B, which is how much are you multiplying by, would be 2. So you would have y equals 12 times 2 to the x power. And it says I want to know how many I'm going to have after 6 years. So I'm just going to plug in the number 6. So if, again, I type that in on my calculator, I get 768 rabbits. All right, thank you guys so much for watching, and I will see you for some practice in class tomorrow. Have a great day.